Section 5.4 is medians and altitudes. So the median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. So a median would start at the vertex and go to the midpoint of the opposite side. And that's what we would call a median. Okay, so now that we know that, Theorem 5.8 is concurrency of medians theorem. The medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. All right, first let's draw our medians. So again, we're going to start with a basic triangle. A, B, C. Drawing my medians means I'm finding the midpoint of each side. And I'll label those X, Y, Z. So my medians from the vertex to the midpoint of the opposite side, from the vertex to the midpoint of the opposite side, and from the vertex to the midpoint of the opposite side. And that's the point of concurrency in the middle P. And so our statement says that not only are they concurrent, but that point is 2/3 of the distance from the vertex to the midpoint of the opposite side. So this point P is 2/3 of the distance from C to Z, from A to Y, from B to X. In other words, CP is 2/3 the distance of CZ. Let me get a different color here. So CP is 2/3 of the total distance. AP is 2/3 of the distance of AY, and BP is 2/3 of the distance from B to X. So that's our concurrency of medians theorem. So a little bit more of information about that. The point of concurrency of the medians is called the centroid of the triangle. And the point is also called the center of gravity because it's the point where the triangular shape will balance. So again, the centroid is the word that we're really worried about. Okay, the altitude of a triangle is the perpendicular segment from a vertex of the triangle to the line containing the opposite side. And an altitude can be inside or outside of the triangle, or it can be actually a side of the triangle. So let's start with a triangle that looks something like this. So an altitude, again, goes from the vertex to the line containing the opposite side. Now it doesn't say it has to go to the opposite side. So here's a vertex. I want to draw it perpendicular to this line. So to be perpendicular, this altitude, whoops, go back. This altitude has to be perpendicular to that side. So this particular altitude is outside of the triangle. This altitude is inside of the triangle. This altitude has to be perpendicular to my other side, so it also is going to be outside of the triangle. Okay, so sometimes the altitude will be inside or outside, and it can even lay right along the edge of the triangle if it's a right angle. So if I have a right angle triangle, it's already perpendicular, this side would be an altitude already. Okay? So the lines, concurrency of altitudes. So again, our altitudes are going to concur or land in the same spot. Let's go back. If I extended these altitudes, okay, they would have a point of concurrency. Okay, so The lines that contain the altitudes of the triangle are concurrent. The point of concurrency is called the orthocenter of the triangle. The orthocenter can be inside, on, or outside. So again, we've got some more terms here of special segments that have a point of concurrency, and we have a special name for that. The last thing I want you to do is to look at your books for special segments and lines and triangles on page 312. If you don't have your book with you right now, make a note to be sure that when you get to class or get to school that you use that, that you take a look at page 312. I would copy that into your notes so that you have a summary of all of those special segments and their points of concurrency. And that is it.